Today's video lesson is on triangles and angles. We'll learn about parts of a triangle and how to name it, different ways to classify a triangle by its sides and its angles, and theorems that explain properties of triangles. We'll look at comparing and contrasting, which is a skill that can be applied to many areas of study. A triangle is defined in geometry as a shape formed by three segments joining three non-collinear points. The parts of a triangle are labeled on the right drawing. We have the vertex, which is a point. There are three vertices of any triangle. We have the sides of the triangle. When we're referring to the opposite side of a triangle, opposite side means across from a particular angle. So the opposite side of angle C, as outlined, would be side or segment AB. Remember, sides are segments. An adjacent side to an angle, angle C in this case, would be side BC and side AC. The symbol for a triangle, triangle ABC, is listed at the bottom here. We classify triangles by two different ways. First, by sides. We have equilateral, which are three congruent sides. Isosceles, which is defined in geometry as having at least two congruent sides. The parts of the isosceles triangle are the legs, which are the congruent sides. You can see by the markings that they're marked congruent. And then the other side that's not congruent necessarily is called the base of the isosceles triangle. We have a scalene triangle, which has no congruent sides. Notice it has 1, 2, and 3 markings. These indicate these are all different side lengths. We can also classify triangles by angles. If it has 3 acute angles, remember acute means less than 90 degrees. That would be, in this case, you can see 3 different markings listed by all acute angles. They don't have to be the same size to be an acute triangle. We have an equiangular. This is the triangle where there are 3 congruent angles. So 3 angles that are all acute angles. This time you can see they're all marked congruent. A right triangle has 1 right angle. We've already studied the Pythagorean theorem, so these we know are the 2 legs that make up the right angle and the hypotenuse, which is across from the right angle. We have an obtuse angled triangle, which is called an obtuse triangle. 1 obtuse angle, which in this case is angle C. The other 2 angles would have to be acute angles. Triangle sum theorem tells us about the angles of any triangle. The sum of all 3 interior angles of every triangle equals 180 degrees. So if we take the measure of A plus the measure of angle B plus the measure of angle C, for example, from a triangle like the one above, no matter what the triangle, the sum is 180. Exterior angle theorem tells us that the exterior angle, that is an angle outside of the triangle, equals the sum of the 2 non-adjacent interior angles. My example shows that angle 1 outside of the triangle equals angle A plus angle B. An exterior angle in geometry, we have to remember, is defined as being a linear pair with any angle outside of it, not an angle that would be vertical. So if I were to draw a line extending this, we have to make sure that the exterior angle is linear paired with the angle inside of the triangle. A corollary is a smaller version or a part of a theorem. So a corollary to triangle sum theorem says the acute angles of a right triangle are complementary. So in other words, we know that angle A plus angle C have to equal 90 degrees since we already have 90 degrees taken up by the right angle. Let's take a look at examples for solving with triangles. Here's an example of 3 angles given in a triangle. I drew a triangle, marked the angles according to what's listed. We know that Z has to equal 90, so I know that it's a right angle at Z. To solve this, there's 2 ways to solve it. Simplest way to solve is we know that all 3 angles equal 180, so take x minus 15 plus 2x minus 165 plus the 90 equals 180. Simpler way we could do this, since we know the corollary to the triangle sum theorem, we know that these two angles, W and Y, together have to equal 90 degrees, because we've already taken up 90 degrees over here with angle Z. I'll leave it set up the same. It'll be solved the same way. If we add the x's together, combine like terms, 2x plus 1x equals 3x. Negative 15 and negative 165 would be negative 180. So I'll just do it step by step so you can see all the steps. Plus the 90, we'll do one more step and then finish solving it, equals 180. Now I'll finish combining these two terms together, the non-x's. So 3x minus 90 equals 180. Add 90 to both sides. Three x equals 270 divided by 3. So x equals 90. Go back and figure out the measure of the angles. 90 minus 15 would equal 75 degrees. We take 2 times 90, which is 180 minus 165 equals 15 degrees. And that problem is finished. Go to the next example. This time we have two remote interior angles and an exterior angle. We know that the exterior angle, 2x minus 11, equals the sum of the two remote interior or non-adjacent angles, so x plus 72. Bring the x's to the left, so x minus 11 equals 72. Add 11 to the right. And we get x, I'll bring it over here, x equals 83. So this angle is 83 degrees. We can also find the third angle very easily by adding 83 plus 72 and subtracting from 180. Our objective though in the problem is to simply figure out what x equals. So we know that this exterior angle right here is 2 times 83 minus 11. Or 155 degrees. And it should equal that. 83 plus 72 is also 155. And that's it for our lesson for today.